8.4 notes, which we are reviewing the cosine ratio. So what is the cosine ratio and how can we use it to solve for missing sides in a right triangle? So as you've already learned about the tangent and the sine ratio, it's a relationship between either the opposite side divided by the adjacent side, or sine for that matter is the opposite side divided by the hypotenuse. Well, the cosine ratio is the cosine of any angle theta, that's what that means, is equal to the side that's adjacent to angle theta divided by the hypotenuse of that right triangle. You can see it here in the acronym. Here's cosine, see adjacent divided by hypotenuse. SOHCAHTOA to help you just kind of remember what that means. So if we're looking at angle theta, which is down here, right? Angle theta, so we're looking at the side that's adjacent to it. So in that case, it would be this side adjacent to angle theta divided by the hypotenuse, which is always across from the right angle. So the side we're not interested in is the opposite leg, not for cosine. Moving on, finding the cosine ratio in a right triangle. So similarly to the tangent and sine ratio, when you are asked for the cosine of an angle, you are not being asked for the angle measure. You are being asked for the cosine ratio of that specific acute angle in the triangle. The cosine ratio of any acute angle is that angle's adjacent side to the hypotenuse. So let's try a couple here. What is the cosine of angle C? So let's look it up here. Angle C is right here, this angle in the top corner. The cosine ratio says that what? The cosine of angle C is equal to the adjacent side to angle C divided by the hypotenuse. So we can say that the adjacent side to angle C is going to be 6. It is not going to be 10 because 10 has a special side name. That's the hypotenuse. It's across from the right angle. So the adjacent side to angle C is 6. And the hypotenuse of the right triangle, again, always across from the right angle, that's going to be 10. So we can say that the cosine of angle C is 6 divided by 10, which reduces to 3/5. Notice how it's not an angle measure. It's simply the ratio of that angle's adjacent side, 6, divided by the hypotenuse, 10. 6 over 10 is 3/5. Next question, what is the cosine of angle B? So now we're doing the same exact thing. We're just looking at angle B instead. So angle B is over here towards the bottom of the triangle, that acute angle. The hypotenuse is still 10. That doesn't change, but the adjacent side definitely changes. Notice how 6 is not adjacent. It's opposite. 8 is adjacent. That means right next to it. So we can say that the cosine of angle B is equal to the adjacent side divided by the hypotenuse. So we can say that the cosine ratio of angle B is the adjacent side 8 divided by the hypotenuse of 10, which reduces to 4/5. Simple as that. Let's move on to a couple more examples here. Make sure these all get into your notes, everything. So it says, let's use the cosine ratio to solve for the missing side. So notice how the given angle given to us is 31 degrees. Notice how we are solving for the hypotenuse of the right triangle, and another side that's given to us is the adjacent side. It is adjacent to this 31-degree angle. So we're going to use cosine. We're going to use the cosine ratio. So we're going to say the cosine of 31 degrees is equal to the adjacent side divided by the hypotenuse. That's supposed to be a D. So we can say that the adjacent side is 7.4, adjacent to 31 degrees that is, and the hypotenuse always across from the right angle. That's going to be what we're solving for, x. So we're going to say the cosine of 31 degrees. So at this point, we're going to punch it into our calculator and figure out what this decimal ratio is. So I'm going to write 31 cosine, and we can see that it is 85717 if we round it correctly. So 0.85717 is equal to the adjacent side, 7.4 over the hypotenuse, x. We're going to put this funky decimal over 1, and we're going to solve this by cross multiplying. So 0.85717x is equal to 7.4. And to solve for x, we're going to divide both sides by that cosine 31 ratio. And there we go. So now we can say x is approximately. So let's take our calculator and figure out what that is. So I'm going to say 7.4 divided by 0.85717. So let me clear that. Try again. 7.4 divided by 0.85717. And that's going to come out to 8.6. So we're going to say x is approximately 8.6 inches. That is what the hypotenuse length is approximately. Let's try one more example using the cosine ratio. So we want to use the cosine ratio in this example because the angle that's given to us, 14 degrees, we can see that what we are given the hypotenuse of the right triangle, it's across from the right angle, and then we are solving for the adjacent side to the 14-degree angle. So we want to use the cosine ratio because that involves adjacent and hypotenuse. So I'm going to say the cosine of some angle theta is equal to the adjacent side divided by the hypotenuse. So the cosine of angle theta, in this case it's going to be our 14-degree angle because that's the one that's given to us, is equal to the adjacent side. Well, adjacent to the 14-degree angle is x. That's what we're solving for. And then, of course, the hypotenuse is 13.4. So we're just going to plug those values in and work it out. So I'm going to say the cosine of theta, so 14 degrees is our angle, is equal to the adjacent side x over the hypotenuse of 13.4. Let's figure out what the decimal ratio is for cosine 14. I get 97029 or 30. So I'm going to say 0.97030. If I'm rounding correctly, I'm going to put that over 1, and that's equal to x over 13.4. And then I'm going to solve by cross multiplying. So 1 times x is approximately, and then let's just put this into our calculator. So 13.4 times 0.97030, and we get 13 exactly, right? If we round it, not exact, but if we round it, it just rounds flat to 13, 13.002, we can just say 13. So x is approximately 13 inches in length, and that is this side length right there. And we use the cosine ratio to solve for that missing side. For your summary, paragraph, name the 3 different trig ratios that we can use to solve for missing sides in right triangles. What are those 3 different ratios? What is the acronym that we can use to help us remember those ratios? I'll give you a hint. It's right up there if you need it. Maybe draw a couple of pictures to help you explain your summary a little bit better as well.